Today is day 2 of section 9.2, and what's going on here is we're continuing with significance tests about population proportions, except we're going to incorporate 2 new things. What's the connection between the confidence interval and the significance test, and how do we extract information from computer printouts? Specifically, your book uses Minitab as its example of a computer printout. So let's dive right into an example here. It says, according to the Center for Disease Control and Prevention website, 50% of high school students have never smoked a cigarette. Tayon wonders whether this national result holds true in his large urban high school. For his AP Stack Class project, Tayon surveys a simple random sample of 150 students from the school. He gets responses from all 150, and they say, and 90 say they have never smoked a cigarette. What should Tayon conclude? So our baseline comparison here is, according to the national website, 50% of high school students have never smoked a cigarette. So that's going to be our hoe. It doesn't specify whether Tayon wants to show greater than or less than. He just wants to ask, is it true for his urban high school? So the ha is going to be not equal to as opposed to a greater than or less than. Remember that whatever you're using for your variable here, which for now is either going to be a p or a mu, make sure that's specifically defined. A couple of details to pay attention to here. The proportion of all students in Tayon's school who would say they have never smoked a cigarette. Okay, don't say or don't write who did say they would have smoked cigarettes. Did saying implies with that tense of the verb that that's the sample as opposed to the population. The other thing here is don't say or don't state have never smoked cigarettes. Having never smoked cigarettes and would say they've never smoked cigarettes could be 2 different things. So in general, pay attention to the wording here. Tense of the verb matters. Be as close as you can to match the wording in the problem. All right, because it's not the focus of what we're working on, this particular problem is skipping over the conditions. For a free response question, they should be addressed in detail. As far as getting your test statistic or calculations in general, if the problem didn't state what the population, what the sample proportion was, you should show where that comes from. You need to state test statistic, whether it's a Z or a T, in the final answer. The most thorough thing you could do for partial credit, blank formula, plug in the numbers, final answer. Since we got a positive Z value, we're going to get the area to the right of that on a normal standard curve. And then because this is a 2-tailed or a non-directional test, we would double that number for the p-value. Okay, as far as the conclusion goes, we want to compare that directly to our alpha level. Because our p-value of 0.0143 is less than alpha is equal to 0.05, we reject the hoe. Remember, you have to specifically make that comparison with the greater than, less than. If your p-value is less than your alpha, you're always rejecting, and that means you have evidence to support your ha. We have convincing evidence that the proportion of all students at Tayon School who would say they have never smoked cigarettes differs from the national result of 0.5. Okay. Now, on to how would this connect to confidence intervals. Okay, the result of a significance test is basically a decision to reject the hoe or fail to reject the hoe. When we reject the hoe, we're left wondering what the actual proportion P might be. A confidence interval might shed some light on this issue. So again, in the interest of time, and it's not the focus of what we're trying to accomplish today, all the conditions for the confidence interval have been met. So we have our sample proportion, our Z star, standard error, plug in the numbers, and that gives us our confidence interval. So we are 95% confident that the interval from 0.522 to 0.678 captures the true proportion of students at Tayon School who would say they have never smoked a cigarette. All right, so what's the connection between the results that we got from our confidence interval with what we got from our significance test? Okay, there is a link between confidence intervals and two-sided tests. The 95% confidence interval gives us an approximate range of P's that would not be rejected by a two-sided test at the 0.05 significance level. Confidence intervals provide additional information that significance tests do not, namely a set of plausible values for the true population parameter P. A two-sided test of Ho, P is equal to P, it's 0, at a significance level alpha gives roughly the same conclusion as the 100, 1 minus a% confidence interval. And so let's go back to the example here to kind of flesh that out in more detail. That's a little bit abstract to wrap your brain around. Okay, we're 95% confident that the true proportion of Taeyeon's students at his high school would say between 0.52 and 0.67 that they never smoked at high school? Never smoked a cigarette, rather. Now, 0.5 is not in that interval. So if we are 95% confident that this is the true correct interval, that means at a 0.05 alpha level, the 95% would correspond to 0.05, and 90% would correspond to 0.10, etc. We can reject the Ho being that. I guess we're going to go back one more slide. Turned the wrong way. The Ho being that the true proportion was 0.5. Now, in this slide, or in this part of the slide right here, it specifically says, where did it say? I'm looking for the wording here. Gives roughly the same conclusion as. Okay, the reason why it's roughly and not an exactly is the fact of, in our test statistic here, we're working off of the P's from our Ho and our Ha, and the confidence interval we're working off the P-hats. So because these are slightly different, the results can be slightly different. Now, in a case where our confidence interval is 0.522 to 0.678, 0.522 is far enough away from that Ho value of 0.5 where we can be pretty sure that the results are going to connect with each other. If this was like 0.501 or something real close to the 0.5, then we get into that gray area of we probably have to do a little bit more work to investigate. All right, let's look at a couple more examples that illustrate this idea. This is from our textbook, one of the practice problems. A Gallup poll found that 59% of the people in its sample said yes when asked, would you like to lose weight? Gallup announced, for results based on this total sample of national adults, one can say with 95% confidence that the margin of error is plus or minus 3 percentage points. Does this interval provide convincing evidence that the actual proportion of U.S. adults who would say they want to lose weight differs from 55%? So, the answer to this is going to be yes. The 50, where does it give that number right there? The 59% plus or minus 3 percentage points goes from 0.56 to 0.62. So that's the confidence interval. Since 0.55 is not in that confidence interval, that would lead us to think that we're looking at a situation where we can reject the hoe, or we have evidence that this is not true, or that the weight does, the percentage of people that want to lose weight differs from 0.55. So yes, because 5.5 is not included in that confidence interval, it is not a plausible value for the true proportion of U.S. adults who would say they want to lose weight. In other words, we have convincing evidence that the true proportion of adults who would say they want to lose weight differs from 0.55. All right, continuing with the same setting. Nope, different setting. The National Center for Health Statistics reports on the proportion of Americans who smoke tobacco. Although the proportion decreased throughout the 90s, from 2004 to 2006, there was little change in the proportion of Americans who smoked. 21%. A random sample taken this year of 400 Americans found 78 who smoked. The 90% confidence interval for this study is. So they're already telling us what the confidence interval is. Use the confidence interval to test the hypotheses at an alpha level of 0.01 that the population proportion of Americans who smoke has changed since 2006. And this is our hoe and our ha. The p equal to 0.21, the ha p not equal to 0.21. Okay, so what we have to make sure lines up in order to make a good conclusion here is the fact of it's a 90% confidence interval with an alpha level of 0.10. If that's 95, that would have to be 0.05. If that was, say, something like 97, this would have to be 0.03. Okay, the other thing is it needs to be a two-tailed test corresponding with the confidence interval. If it's a one-tailed test, then you have to do some tweaking. And I don't recall whether we get to that in this PowerPoint or not. That might be a future lesson. So, for the example that we just finished, this number was outside that interval. When this number is outside that interval, then that corresponds to a rejecting the hoe. We have evidence for the ha. Okay, if this number is inside that interval, which it is here, that means we fail to reject. We do not have evidence for the ha. So since the 0.21 is contained within our 90% confidence interval, we fail to reject the hoe at an alpha level of 0.1. We do not have sufficient evidence to support the claim that the population proportion of Americans who smoke has changed since 2006. All right. So what we've done so far is made the connection between the information we get from a confidence interval with the information we get from a significance test. The next main theme for today is what kind of information do we extract from computer printouts. All right, so here's our setting. What proportion of students are willing to report cheating by other students? A student project put this question to a simple random sample of 172 undergraduates at a large university. You witness 2 students cheating on a quiz. Do you go to the professor? The mini-tab output below shows the results of the significance test and the 95% confidence interval based on the survey data. So the test and CI for one proportion, the test of P is equal to 0.15 versus not equal to 0.15. Should I zoom in? I don't know if that can be seen very well. Refocus. Okay, so we have sample number 1. Well, it is a 1 sample, so there is no number 2. X is the 19. That means that 19 people said that they would be going to a professor out of a sample size of 172. There's our sample proportion, or our p-hat, 19 divided by the 172. There's our 95% confidence interval. The z-value, that's our test statistic, and our p-value, which we've already talked about. So that's the information that would be typically given to you in one of these printouts. All right, so what are they asking us for? Define the parameter of interest. Okay, the parameter of interest is P equal to the true proportion of undergraduates at this large university who would be willing to report cheating by other students. All right, a couple of details here. Who would be willing to report as opposed to who did report. And I think that's about it. Nothing else really needs to be said about that. All right, next one. This is continuing with the same scenario. Check the conditions for performing the significance test. So random, the sample is randomly selected. That's very poor right there. There's nothing specific to this problem. That's unlikely. Ooh, I'm sorry. I was off the screen here. I forgot I zoomed out, or zoomed in rather. Let's go back to the beginning here. Check the conditions for performing a significance test. So, random, the sample was randomly selected. That's very poor. That's very unlikely to get you full credit right here. There has to be something that connects specifically to this problem. We have a simple random sample of 172 undergraduates. The 172 undergraduates, that would be something specific to this problem. Not so good with that. Okay, the sample size of 172 is less than 10% of all graduates at this large university. I think it would be safer to write, we can assume if it's a large university that's less than 10%. Again, not thrilled with this wording right here. I would prefer something a little bit better. For our large counts, in this case here, that's pretty solid. They're showing a blank formula, numbers plugged in, comparing them to 10. I think we're good with that. That's pretty solid. Okay, interpreting the p-value. Okay, the general interpretation of the p-value is assuming the HO is true, what's the probability of getting results at least as extreme as this? That's the basic flow that we want here. So one thing that would be good to start off with is stating what the p-value is. That shows you know where to find it on the computer printout. And then on to the interpretation. Assuming that the true proportion of undergraduates at this large university who would report cheating is 0.15, so that's assuming the HO is true. There is a 0.146 probability of getting a sample proportion that is at least as different from 0.15 as the proportion in this sample. That's the specific, at least as extreme as these. Okay, same setting. Next question. Do these data give convincing evidence that the actual population proportion differs from 0.15? Justify your answer with the appropriate evidence. So, with the test of 0.15 versus not 0.15, where we would test HO, P is equal to 0.15 versus the HA, P not equal to 0.15, specifically stating what P is. Because the p-value of 0.146 is greater than a 0.05, make that specific comparison. If this is bigger than that, we fail to reject. We do not have evidence to support the HA. In other words, that the evidence that the true proportion of undergraduates at this large university who report cheating differs from the 0.15. Okay, so that would be focusing our answer based on a significance test. What about focusing our answer based on a confidence interval? So, the other thing we could do is focus on the fact of the 0.15, zoom in on this, it's not the greatest photocopy. The 0.15 is included in that confidence interval. 0.157 is the upper end of the confidence interval here. So because the 0.15 is contained in that confidence interval, we fail to reject the HO at an alpha level of 0.05. We do not have sufficient evidence to support the claim, blah, blah. Finishes up with the last sentence being the same thing. So, if this number is in that confidence interval, that's a fail to reject. If this number is outside that confidence interval, we reject. And that's it. I thought there was one more slide on this. I guess I was wrong. So that is a wrap for today.